Morning, Chris. Hey, Chris, write your name, your ID in the, you did it, thanks. Hopefully we'll get some more people here. Just got a couple minutes. Morning, Henry. Write your ID, please. Good morning, Evan. Can you write your ID, please? It'd be nice if you guys turned your video on. It's so nice to see you. If you want to take yourselves off mute, you can do that and we can talk until we get started too. That'd be nice. All right, those of you who've joined us, please write your ID numbers in the chat box, please. Okay, Evan, that's fine, don't worry. Thank you, Evan. Thanks, Sophie. Good to see you, Blake. How are you?
Okay.
Good. If you've just joined us, guys, write your IDs in the chat box, please. Have you guys done anything cool for any of your classes? I think next week we're going to take a virtual field trip. Have you done anything like that yet?
Good morning, Miss Gross.
Good morning. How are you doing, David?
Good, and you?
Good. It's good to hear your voice. What have you been up to?
Trying to stay active and doing work.
That's good. Me too. I've been doing lots of bike riding. I've been playing some catch with my son and riding my bike a lot. Doing some sit-ups. It's like when I sit in front of the computer, I want to eat, so I have to work it all off. Hey guys, if you haven't yet, please write your ID numbers in the chat box. Thanks, David. Bless you. All right, if you're just joining us, write your ID number in the chat box, please. Thanks, Justin. Got a lot of people joining us, that's good. Morrison, can you write your number in the chat box, please, your ID? And I think Graham, I need yours. And Isabella. Oh, Isabella did hers, never mind, thanks. Isabella, okay, Morrison. Zero 035, Nicholas, thanks. All right. Well, if you know anybody who's not here, maybe text them and let them know that we're starting, just to give them a little reminder. I like your hair, Chris. It's getting long. I offered him to cut his hair, but he didn't like that idea. We can't see the barber yet, so I think he's gonna have really long hair by the time we finish this. Let's see who else I can see. Not everybody likes to turn their video on, but. Oh, hi, Justin. Good to see you. And who's that? Bakari, I see
Hey,
half your face. Hi, Justin. Let me see the rest of your face, Bakari. Much better.
Hello.
Hello, hello. And who's this? Is that Evan? I see half of Evan's face. That's better. Your hair looks just fine, Evan. Don't worry. Okay, I know like my hair is a mess, but I'm not gonna worry about it. All right, so here we go. I think whoever is joining us has joined us already. Hi, Nicholas. How are you? It's nice because you can wear your hoodie at home, right? All right, let me turn this thing, close all this stuff. All right, so this week we are doing a lesson on microplastics. The objective of the lesson is to evaluate competing design solutions for maintaining biodiversity and ecosystem services. Now this is a lesson that, this is an objective that we've observed in the past. So it shouldn't sound new to you, but just in case, let me just break down what that means. It just means that we're going to be looking at solutions for helping the environment. We're going to evaluate the solution and see how it helps us to maintain biodiversity and ecosystem services. So ecosystem services are the things that the ecosystems just give us inherently, like food, medicine, beauty, oxygen. Okay, so hopefully we'll understand how dealing with microplastics in a better way, or dealing with plastics in general, is going to help us. Okay, so the first thing that you need to do is you need to click on the assignment. So on the link, click and make sure that you copy and paste the questions into a Google Doc, which I've done already here, so I'm ready. And here it says, before we start reading, what are microplastics? So I think we can make a pretty suitable judgment or guess on what microplastics are, because we know what micro means. Micro means, shout it out.
Small.
Okay, and plastics,
Small.
we know plastic. Small plastics, okay. So essentially what happens to plastics over time is they break down. They don't break down completely though, okay? They're non-biodegradable, which means they can't completely Abed?
Yes.
What do you think? Why would we be worried about microplastics? Anybody? Well, if we don't know yet, then maybe we should go ahead and start reading.
Miss Gross.
Yes, sir.
We should be worried
They pollute
because
the environment.
and the animals will start eating them.
Okay, perfect. Good job. So they're non-biodegradable. they pollute the environment, and we and other animals can consume them. So they affect our health. Okay. Actually, some plastics are even carcinogenic, which means they can cause cancer. So that's very worrisome if we're consuming these things, okay? And don't think that we're not, okay? Just because we don't necessarily see them doesn't mean that we're not consuming them. All right, so next we need to go ahead and open this reading assignment. Make sure that, well, you're looking with me, so you don't need to open it, but it's called Help for a World Drowning in Microplastics. Look how teeny tiny those things are. Some of them, like the one that's like right there, you wouldn't even notice it. You could easily drink that up without even knowing. So before we begin reading, I should observe that this week is Spirit Week, and I was much more excited about yesterday's theme than today's theme, which was to bring your own pet or stuffed animal. But today it's bring your own cup. Did anybody bring their own cup and want to like share about their cup? Or if you want to share what you shared yesterday about your animal or favorite stuffed animal, you can do so. Let's do that. I had my little teddy bear. It's actually not mine, but it's been in the family for a while, and so I can claim it. Nobody else wants to claim it because it lost an eye, and it's gotten a little bit bedraggled, a little bit falling apart. But I've had lots of pets in the past, and I didn't bring my pet today. And I don't really have a favorite cup, but I have my glass of water, and I'm very happy to have it because that's probably what. Oh, look at Blake's doggy. So I'm going to put you on speaker view if I can, Blake, so everybody can see your dog. And I think somebody else joined us, so I'm just going to let them join us. So Blake, in order for me to put you on speaker view, you need to say something, okay? Say something about your dog. Okay, let me go back here and see if I can try again. Blake, can you hear me? Take yourself off mute and say something about your dog.
Hello, this is Bo.
What's his name?
Bo.
Poe. And who named him?
It's Bo. B-O.
Say again, you're breaking up.
His name is Bo.
Bo. Who named him?
The family that had him before us.
Okay. You have a story to tell us about Bo? Maybe how you got him or like your favorite day with him?
Not really, no.
Not really? Okay. Is he doing okay? He's liking all the extra time you spend with him? All right. I had pets all the time growing up. So I had a little dog named Chocolate. He was brown and tiny. And then I had a dog named Tanny. She was tan. She was the best because we lived in a really small town. And she would actually, without me taking her on a leash, she would walk me to school. And then when school was done, I would normally walk home alone, but she was there to pick me up without anybody else. She just knew when it was time, and she was there waiting at the schoolyard to walk me home. So that was really cool. That was before leash laws. They didn't have leash laws in my little town. And then growing up, I had some other dogs. I had an Irish setter. He was a beautiful red dog. And we had a Brittany, which is a white and red dog. And more recently, we had a Jack Russell Terrier. So that wasn't when I was a little kid, and I've had cats too. Lots of pets in my life. They're great, except for when you're old and you have to clean up after them. That's when it's harder. All
It's
right,
gross. I have a
yeah.
stuffed animal.
Let me see, Justin.
I've had this thing since I was like 4.
A little pinguino,
Yep.
little penguin. Okay, cute.
Thank you.
No, thank you for sharing, Justin. All right, let's get back to, I'm going to share with you our reading here. And all right. So look around you. How many plastic items do you see? If you're like most people, there are probably a lot. Research shows that people recycle only 9% of plastic wastes. The rest, water bottles, pens, shopping bags, can end up in our water, air, and soil. Exposed to light and waves, plastic breaks down into teeny tiny bits. Known as microplastics, they have become a growing concern. That's partly because when they end up in the environment, they also can end up in animals, our food, and our drinking water. So this is actually an answer for one of our questions. Go back to number 1 during reading. It says, how much of our plastic waste is being recycled today? Who is paying attention?
9%.
9%, excellent. Where does the rest of it end up?
In our environment.
Okay. Even in our food and water. So that's the crux of the situation. Everything that we do comes back to us. I've been trying harder and harder since I've become more conscientious of what's going on in the environment to do more and more to help out the environment, or less and less to impact it negatively. And I know some of you have been working on this during your lives as well. But this year, I decided to try to completely cut plastics out of my life. So in terms of anything that I buy at the grocery store, for the most part, I'm trying to do plastic free. So I think the only plastics I brought home within the last month are those little spouts that are on the almond milk. Everything else I've just been conscious about. And so when I need cleaning products, I don't go to the store anymore because I know that they all come in plastics. I just have spent some time researching online where I can get my plastics, or not my plastics, my products without plastics. And so I buy my cleaning products in little cartons now. So I've helped there. And then like when I go to get, because I buy a lot of fish, I don't eat much chicken or beef, but when I go to buy my fish, I'll say, please just wrap it in paper. And so they wrap it in paper rather than getting the styrofoam tray with the plastic over the top. You just have to ask for what you want and go out and get what you want, and you'll find it. There are other options. The only one that I found that I couldn't find without was the almond milk, but I'm gonna keep working on researching that one. And hopefully, well, I even tried making my own almond milk, but that's very time consuming, and being a teacher and a mom doesn't really allow for making almond milk. So what I'm gonna be doing is just trying to find a place out there where I can buy my milk without a plastic top. I encourage you guys all to do the same. I know that we've all been affected going out to the beaches and seeing the beach awash with plastics, or seeing, at least if you don't go to the beach, probably videos of that, and animals, marine life with their guts full of plastic dead on the beach because they can't digest those things. So the next question says, what amount of plastics do Americans consume, eat, and drink each year? So I'm sure this is addressed in the next part right here. Who would like to read? Any volunteers?
Sure.
Thank you.
The most recent estimates suggest that Americans alone eat or drink some 70,000 of these polluting microplastics bits each year. Discarding plastic is not the only source of them. Some bits are made on purpose. for use in skincare products and toothpaste. They're used to scrub away dead skin in the cavity, causing material on teeth. When we shower or rinse our mouths, those microplastics go down the drain. From there, they end up in our waterways.
Okay, let me ask you to pause there for a minute, because I did not realize this years ago that when I was exfoliating my skin, you know, with those special gels that they have, that it actually contained plastics. We need to know before we ingest something, eat it, or before we use something for skin care products, what's in it and if it's good for us or not. So please make sure you read your ingredients before you put something on your skin. It could be bad for you or for the environment or both. So there's a couple answers to the questions we have here. The first one is that there are 70,000 they believe for us that we're ingesting each year. That's a bunch. So hopefully we're using water filters when we drink water. That's a good idea. But the best thing is to eliminate these things from our lives so we don't have to worry about this. Name 2 or more way plastics enter the environment. Well, they just told us what? About skin cleansers and about toothpaste. Can I hear from somebody else besides Justin? Not that I don't want to hear from you, Justin, just that I'd like to hear from some other people. Evan, were you listening? Evan, don't take yourself off video. I want to see your face. Evan, do you know what else, other ways that those plastics get into the environment? David? All right, let's go back and do you have an answer for us, David?
For number 4?
Yes, sir.
Yes.
Okay, what is the answer, please?
I just have to try to figure out how to get it off of full screen.
Let's go back to the paragraph we just read. It's here.
Skin products and toothpaste.
Facial
And
exfoliator.
dead skin.
Okay, so skin care products and some toothpaste. I should put some for both of these. Some skincare products and toothpastes contain microplastics. See, this is just an example of how businesses do not care, and they'll put anything in their product that you think will cause you to buy the product. So if you stop being consumers of those products, they'll have to stop making those products because they won't make any money if they keep making them. But if we continue to consume these products that are bad, guess what? They're going to keep making them because all they're worried about is making a buck. Number 5, in what ways might we end up consuming plastics? Let's go to the reading.
In our
Exactly. We don't even need to read that to know the answer. It's going to be in our food and water. Thank you. Who was that? Was that Sophie? Sophie, can you continue reading for us? Thank you. At the top of the page, please.
researchers have even shown that washing clothes made of fleece and other types of plastic sheds bits of lint. Those fibers also go down the drains and into water. Scientists began reporting microplastics in the ocean as far back as the 1970s. Since then, several hundred studies have shown that microplastics taint the environment. This includes the world's oceans, lakes, and rivers.
Okay, stop there for just a minute. I want you guys to go back to that prior paragraph. She read that our clothes are even made of plastics. So that means that we have to be conscientious about what we're buying. We have to look at our labels before we buy things if we want to care enough. So that means, well, what are the natural fibers? We have cotton, silk, linen, wool, hemp, which comes from the marijuana plant. They use it for making natural fibers, and there's others, but you need to know what's natural and what's not natural and try to make wise consumer choices based on what's right. All right, Sophie, can you continue, please? You want somebody else to read?
Yes, please.
Okay. Abed, would you read for us, please?
Where are you reading?
At the top?
But researchers?
Yeah.
All right, but research is underway to slow the growth of this pollution and perhaps clean up some of what's already out there. The problem with plastics. Our drinking waters come from lakes, rivers, and groundwater aquifers. Any of these may be tainted with microplastics. Our bodies can poop out plastics we've ingested, but no one knows how long it takes for them to move through the body, says Sam Athey. She studies the surfaces of microplastics at the University of Toronto in Canada. The longer microplastics stay in our bodies, she says, the greater our exposure to them. Researchers don't yet know the risks, said Athey, but she finds reasons to be cautious. One is that plastic is made from oil and includes many different petroleum-based ingredients. Scientists don't yet know how many of these might be toxic. Ingredients in some plastic, like polyvinyl chloride, can cause cancer, and thiouretes. Yes.
I couldn't hear you because you were breaking up, so I'm going to pass it on to somebody else. Do you have a baby brother or sister?
It's a baby cousin.
Oh, a baby cousin.
It's a boy.
Aw, so sweet.
It's a boy.
All right, I'm going to just ask you all to look here with the questions, because I think he answered a couple questions in those past paragraphs. It says, in what way might we end up consuming plastics? I think Sophie said earlier that we can just drink them or eat them, basically. So we can eat or drink them. How does the body get rid of them? He said that we poop them out.
Pooping, yeah.
That's basic. All right. And you can write that. Yuck. All right, list 3 ways we can avoid buying plastic items. So I'm sure this is going to stay in the text, but anybody want to go ahead and make some educated guesses based on what you've learned in the past?
Stop using those plastic bags from Publix.
Good. Something else? Henry?
Straws.
Ooh, good. Stop using plastic straws and lids too, because like every time you go to Starbucks, they put a plastic lid on your coffee or tea. All right, something else?
Plastic water bottles?
Good. All right, we could go on and on about what not to use, but they just asked for 3, so let's stop there. Number 8 says biodegradable goods are replacing some conventional plastic items, but they're not perfect. What 2 problems are there with each of those materials or those materials? So let's see if we can find the answer to that question. So Abed, things kind of got cut off right here. So I'm going to have the next person start where it says ingredients. Nicholas, can you read for us, please?
Excuse me, wait, where are we? Just
at the top.
Ingredients in some plastics, such as polyvinyl chloride, can cause cancer and how do you say that?
Phthalates or phthalates.
Phthalates, used to soften some types of plastics, can mimic the activity of hormones. These false hormones can cause unexpected changes in cells, grow and develop. Such as changes may lead to disease.
All right, keep going, please.
Plastics also can soak up pollution like a sponge. The pesticide DDT and PCBs, which are a type of insulating fluid, are two types of toxic pollution found in plastics floating in the ocean. Plastic bits also have been turning up in fish, birds, corals, and other aquatic animals. That's a problem because plastics does not provide the energy and nutrients these creatures need to grow and thrive.
Great. All right, did we answer any questions there? Not yet. Okay. The case for saying no to plastics or plastic. Isabella, can you read, please?
The simple solution is to not buy plastic items, says Peter Kershaw. He is an independent marine scientist who lives in Norwich, England. He wrote in 2018 a report for the United Nations on alternatives that could help reduce plastic litter in the ocean. Ask yourself, he says, do I really need that plastic bag I carry my shopping home? Or do you really need a plastic straw to drink your soda or milk? Do I keep going?
Please.
The leaders of some countries also have been asking that question. They've decided the answer is no and have banned single-use plastic items. There are things such as packaging that we use once and then we throw away.
One more.
Okay.
Bangladesh.
Bangladesh, Kenya, and New Zealand are three countries that have banned plastic bags. Some U.S. cities and a few states also have banned them. Representing 28 countries, the European Parliament has agreed to ban nearly a dozen single-use plastics by 2021. Europe's ban includes single-use cutlery, plates, straws, and drink straws. Canada announced a plan to ban these two by 2021.
Okay. So their cutlery, that's the silverware that we use, that plastic silverware that we buy sometimes for parties and things. Okay. Such bans are a good start, but scientists say people, what do they say? People must do more. So the promise and peril of biodegradable materials. David, would you read there? David, are you with us? All right, how about Alex? Would you mind reading?
Sure. Let's go. Did you say mine?
I'm sorry?
Did you say David?
I can't hear you. Can you speak up?
Did you say David?
Yes, but
Oh.
Alex is gonna read. So just wait a minute, David, okay?
Okay.
Thank you.
One strategy is to find alternatives to conventional plastics. Some companies are starting to replace single-use plastic items with biodegradable alternatives. These new products are designed to break down into harmless chemicals. Materials decay when microbes feed on them, breaking big molecules into smaller, simple ones, such as carbon dioxide and water. Other living things can feed off on these breakdown products to grow. Traditional plastics take a very long time to decay. That's because it's made from petroleum, and few microbes choose to eat that. Biodegradable plastics, in contrast, is made from biological materials on which many microbes happily dine. These range from trees, sugarcane, and corn and corn stalks to shrimp shells. But there is a problem with such materials, says Crenshaw. They decay only at very high temperatures, typically 50 degrees Celsius, 122 degrees Fahrenheit. Plus, those temperatures must be maintained for several weeks for microbes to do their job. Some cities have industrial compost systems that meet those conditions, but many do not. Instead, biodegradable plastic items can end up in a cold ocean or lake where they can take decades or even centuries to break down, depending on the plastic. Sunlight can speed their breakdown, but scientists recently showed that biodegradable plastics bags were still strong and intact after 3 years outdoors. In that regard, they were not much better than regular plastic. The other problem with biodegradable plastics is that people often toss them into the recycling bin with regular plastic. Once you mix them together and they look the same, so people do it, it makes them harder to recycle the plastic, says Crenshaw.
Thank you. Nice job. All right, so looking at the document that we're completing, biodegradables are good. What are some problems with them though? David? Was that you?
Some
You need to
problem.
Go ahead, speak up.
Okay. Some problem with biodegradable items is that they need like a lot of heat to to go away, and you have to keep the heat for a long time, which may not really be.
Okay, so they require high temperatures to decompose. Was there anything else they mentioned?
That you must have the temperature, like a high temperature for a really long time.
Oh. Okay. All right, excellent. It says, what are two problems? Was there another problem?
They're put in with plastics, like that people mix them up when they are recycled.
Good, Justin. All right. So also, they are often mixed up with non-biodegradables. And so the whole mix is thrown out. In other words, they're not going to recycle it because it's mixed in with the non-biodegradable plastics that are supposed to be recycled, okay? They can't be recycled together. I guess that the ones that are biodegradable really can't be reused as much as the other ones. All right, the next question, number 9, says, how is the water from our laundry adding to the problem? What invention are scientists testing to address this issue? I bet you guys can guess what the answer to this is, because it was addressed a little bit earlier in the article. What did they say was happening?
It makes waterborne plastics.
But why? What's coming out of our clothes?
Lint.
Lint. And what kind of clothes have plastic in them? Would cotton have plastic in it?
No.
Oh,
It shouldn't, unless it's a mix. Some actually are weaved in together with other things. So you have to be careful. Even though it says 98% cotton, it might also have something like elastin in it. Well, elastin is a plastic.
Fleece.
Okay, fleece was one they mentioned that's got plastic in it. So we have to be careful. Let's see what the article says ahead. Can I get you to read next, please? Henry, are you with us?
Yes, I am.
Oh, excellent. Can you start below the next heading, please?
Cleaning clothes has become an enormous source of waterborne plastic. Washing machines tumble and wear down fabrics. This releases lots of little pieces of lint. If the fabric was made from nylon, polyester, or polyethylene, or polyamide, for instance, those lint particles will be plastic. Do I keep reading?
Please.
One 2018 study found that polyester fleece was a big culprit. A study that came out 2 weeks earlier showed that washing a single 6 kilogram, 13-pound load of clothes made from synthetic fabrics could release some 700,000 plastic lint fibers into the wash water. That explains why some researchers are looking for ways to keep that lint from going down the drain. One project has been testing special fibers to catch those fibers, special filters.
Yes.
Fibers. It's being run by researchers at the University of Toronto and Georgian Bay Forever, a local environmental group. This past July, they installed the test filters on washing machines in 100 households in Parry Sound, Ontario. Parry Sound is on the shores of Canada's Georgian Bay. It's part of Lake Huron.
Thank you, Henry. That is a lot of little plastic fibers, 700,000 that go into our drinking water for every single wash of fleece. Wow, it's crazy. So they said they were making a filter, right? It's funny, the filter was made of plastic too. That was pretty ironic. But yeah. Number 10, what device are scientists testing to break down microplastics already polluting rivers, lakes, and oceans, and how does it work? Well, this sounds exciting. Who haven't I heard from? Anybody want to volunteer? David, you haven't read yet. Go ahead. I think we're at the top again, right here.
All right. The local water treatment plants are designed to remove microplastics. So any microplastics from the town's wash will end up in the bay. The test filters are about twice the size of a standard water bottle. In recent tests, they moved roughly 90% of microfibers, notes project leader Lisa Ertl works at the University of Toronto. Testing in our lab shows the filters, work in the controlled settings, she notes. We're curious to see if they work just as well in real people's homes. Whether they do may depend on whether people use the filters properly. For instance, she notes, how often do they change the filter? Do I keep on going?
Please.
Ertl and her team tested the wash water before the filters were installed. They are now repeating those tests to see how well the filters reduce the release of plastic lint.
One more.
The study will run for 2 years. Its results will be shared with the public because Parry Sound has a population of just 6,400. Ertl suspects that the decrease in microplastic fibers will be noticeable.
All right, thank you. Evan, please continue. Evan, are you with us? Oh, he told me earlier his speaker's not working. I forgot. Who haven't I heard from? Graham, read for us, please.
Where?
At the top, please.
Like the ideal solution.
Yes.
The ideal solution would be to not manufacture plastic-based clothing in the first place, says Ergo. But filtering lint out of wash water and then burying it in a landfill would at least keep the pollution out of our waters.
Keep going.
What about the microplastic pollution already polluting rivers, lakes, and the ocean? In July 2019, researchers in Australia reported a potential solution for breaking microplastics into smaller, harmless molecules. They created a nanometer scale coil-shaped tubes made from carbon. These tubes are too small to see, even with a classroom microscope, but they may produce a very visible change in water pollution by breaking down microplastics.
One more.
Here's how they work. The carbon nanotubes are coated in nitrogen when mixed with a compound known as POMS, monosulfate. The nanotubes create new chemicals known as reactive oxygen species, or ROS. These new chemicals crumple microplastics into smaller components.
Okay. So here we have an answer for one of our questions. What device are scientists testing to break down microplastics already polluting rivers, lakes, and oceans, and how does it work? Let's see if we can put this information into our own words, okay? So, how could we say nanometer scale coiled shaped tubes in another way? Do you know what nano, that measurement is, how small it is?
Very small.
Yeah, it's very small. It can be used to measure atoms, okay? So they're testing a even sub-microscopic, because it's not only, I guess it's, you could use some microscopic, some microscopes, just not the compound microscopes we use, but they're using microscopic tubes.
Got some sauce on it?
They said they're made from carbon. They're testing a carbon tubes to see if they can do what? Break down what?
Microplastics.
Good. New chemicals are made. And those help to break down the microplastics even more, okay? All right. Let's finish reading, and there is something at the end of the article that I want to draw your attention to. So this is important that we stick to this till the end. If we don't get all the way through the end within the hour, then I'll just dash on down to the bottom regardless, okay? So would you mind reading next, please, Blake? Have you read yet, Blake? Go ahead and read. And Bakari, you'll go next, okay?
Is it on chemical engineer?
Yes, sir.
Okay. Chemical engineer Jane King led the research. He works at Curtin University in Paris. His team added their carbon nanotubes to 18 milliliters of water tainted with microplastic particles. Then they warmed the water to 120 degrees Celsius or 248 degrees Fahrenheit for 8 hours. Heating the water speeds the process. Manganese embedded within each nanotube made the tubes magnetic. This meant the researchers could use magnets to pull them out of the water for reuse. The treatment reduced the amount of microplastics in the water by about 1/3 to 1/2. Kang's group showed it reported the findings on July 31st, 2019 in the journal Matter.
So how do you guys feel about this solution to this environmental problem?
It's better than just letting it happen.
Okay, can somebody else tell us what they think? Thank you, Justin. That is bad just in heating the water. Bakari?
Yes, ma'am.
Did you hear my question?
No.
Okay, so they're heating the water so that they can help the microplastics to break down, right?
Okay.
What is wrong with heating the water? What does it require to heat water?
I guess a stove, like, or
Energy.
I can't hear anything.
How do you heat your water?
Oh.
Fire.
Boil it.
Boil my water.
Okay, so what does it require to boil or heat your water?
Fire.
Hot water.
Energy.
It requires energy,
Oh.
right?
Yeah.
And so if we're trying to solve one problem, we're creating another problem, which is if we're heating water, we're using energy, and you know that every single time that we use energy, unless we get our energy, well, even when we get our energy from a solar panel, because it takes energy to make solar panels. So anytime we're heating something, it's going to require energy, and that's going to cause possibly pollution, but definitely global warming. Okay, it's going to lead to more global warming. So they're trying to solve one problem, but they're creating another problem. That's not really a good solution. So the solution here is, what's the very, very best solution?
Just stop using plastic.
Very good. So we need to stop using plastics. And since you guys are going to be future consumers, if you're not already consumers, meaning that you're going to go out and you're going to use your money to buy what you want, you're going to have to make the best decisions for our global society, for humanity, and for all wildlife, okay? So it's on us. I shouldn't say you, it's we. Go ahead and read at the top of the page. Where are we? This is not where we're at, is it? No, we read that. Somebody help me out. We're ready for chemicals or further down?
We're at chemicals produced.
All right, go ahead and begin there, Bakari. Thank you.
Chemicals produced by plastics breakdown don't appear very toxic, notes Long Chen. He is an environmental engineer at Northeastern University in Boston, Massachusetts. Chen was not involved in the work. The Australian researchers exposed green algae to water containing microplastic byproducts. After 2 weeks, they saw no change in the algae's growth. Clearly, more research is needed, but the early testing does not appear promising. It's great to have this option as a tool in a toolbox to curb microplastic pollution, says Bart Coleman, He's an environmental scientist at Wageningen. How do you pronounce that?
I'm guessing Wageningen. That's a guess. I didn't check.
Okay, university in the Netherlands. However, researchers caution there still is a lot of work to do. What's more, Coleman says such new programs to clean up plastics should not dismiss us from thinking about what the real problem is. And that's the release of plastic into places where it does not belong.
All right, excellent. Thank you, Bakari. So if you guys page down through the article past all the vocabulary words and definitions, you'll find, oh no, not here, sorry. It's in the document here. Once you've answered your questions, the very last question after reading, so we have 1, 2, and 3. For number 3, it says go to the link. And so I'm gonna click on the link. It says we're going to continue by clicking on the link to sign the petition. This is optional, but I encourage you all to do this. You don't have to be an adult to do this. And then attach your screenshot here and I'll give you extra credit. So I'm going to show you what this looks like. Click on here, sign the petition. I've already done this and I hope you all do it as well. You just click on that and it says you've already signed. So looking here, it says, thank you for signing this petition. We have over 3,000 signatures. This is where you need to take your screenshot, okay? So I've signed it. You can do some additional things if you want, including donating to Sierra Club if you're wanting to do something to help out a very environmentally active organization. Then just copy and paste that screenshot into a Google Doc and then, or no, just straight into this Google Doc that we have here with the questions and answers, okay? So I think you should only have these 3 things to do in the after reading by yourselves, okay? Let's go back to today's objective before we sign off, okay? The objective was to evaluate competing design solutions for maintaining biodiversity and ecosystem services. So they proposed many different solutions for dealing with microplastics. What were some of the solutions that they proposed? Name one. David?
Yes.
Name one thing that they proposed for us to do in order to deal with the problem of microplastics.
They wanted us to use reusable bags, so stop buying plastic bags.
Perfect. Another one, Justin.
To use biodegradable plastics.
Good. Another one, Blake.
The nanotube.
The nanotube mixed with the palms, right?
Yeah, that.
Yes, good. Another one, a bed.
Reduce our use of plastic straws.
Yes, excellent. Bakari.
Uh, to get our water from a fountain instead of like bottled water.
Okay, good. Another one, Graham. Look at number 4.
We can make the skincare toothpaste companies stop containing microplastics.
Yeah, stop putting microplastics in skincare products and toothpaste, or don't consume them. If you don't consume them, you're going to discourage them from making them. Something else, Henry?
I'm not sure.
Okay. I think we touched on all of them. So
Ms. Gross, what about signing that petition?
signing the petition, education, yeah, education and policy, very good. And then the final one that I said would be, and we agreed would be the very best would be which? Chris?
I'm guessing it would be like to find new ways to limit on the use of like plastics.
Okay, just to completely stop using plastics would be the very best thing. Definitely. So I want you guys to consider how you can cut plastics out of your lives, and together we can make this world a better place. Believe it, we can, okay? Is there love out there for a good cause? Good. Thank you guys for joining me. You have a wonderful week, okay? Many blessings to you and your families. Bye.
Bye, Ms. Gross.
Love you.
Bye. Be safe.
You too. Ciao, ciao.
Yeah.
What? Ciao.
Bye.
Bye.